Hi everybody. Next we are going to discuss about the POSIX threads programming in the embedded systems. We have the POSIX thread programming. Mainly we have files, data and coding, like in the rows and columns. And we have the rows we arrange in the register and counter stack in the rows, and it's called a single thread. It is a multiple thread process. We have the files, data and the code. The registers are available in the rows and the counters are available in the row. In the stack, like it will be in multiple row process we have. And also the POSIX thread is a common known as threads. Threads are mainly used in the standard to allow the multiple threads to consist and coexist of within the same process and sharing the resources between the executive of independently and embedded system mainly using and they facilitate the concurrent and to tasks of execution, which will be essential for optimizing performance and responsibilities. And the paths offers in range of the functionality in the embedded systems, which is the threads and mainly used in the other applications and all we can use. The mainly the threads and the synchronization methods, the multiples and contextual variable of thread mechanism and real-time scheduling, and there are the crucial essential applications and it will be very where threading of resources and the constant crucial mechanisms. And thread synchronization of the programming and programming concept for the ensuring the ordinary execution of multiple threads within the concurrent of event, and also coordinating the threads and of multiple processes and resources to prevent the conflict and ensures the data integrity. And multiples of muxes and stempoints were using the threads, and also in another representation synchronization mechanism were using the embedded systems, and also provide the way of control access to share the resources to allow the fixed number of threads, and it will be used in the continuous assignment, and simultaneously often we can use for the finite resources such as the hardware, peripherals and other buffers. Mainly the crucial solutions interrupt handling and the event flag we are using main threads, and synchronization can classify into two: the process synchronization and the thread synchronization. The thread synchronization mainly the execution of mutual executive and internal executive, and the synchronization methods, synchronization blocks and other peripherals we are using in the other status synchronization, different types we are using in the synchronization programming. Thread mainly threads of safety. And thread safety mainly we are using the synchronization and memory visibility and redundancy we are using. For the synchronization, mainly the mechanisms to action the avoid the conflict of and maintain the consistency, and the synchronization primitives like access and conditions of various variables and various facilities between the threads, and ensuring that executive synchronized in a manner and will be using the methodologies here. Thread pool mainly you have methodologies and task queues and task submissions and task executions we are used, and also thread lifespan and resource management, performance optimization, dynamic sizing. This is the POSIX thread programming, where the applications were running in the multiples of going to the task queues, and it will be go for thread pool, and it will be executed in the thread pool execution of POSIX. This is the parallelism and concurrency we are using. Currently, we are how the on the other hand involved in the existence of multiple task process and simultaneously and simultaneously, but not a necessary concurrency we are using. The concurrent programming focus on the managing of execution of multiple tasks and allowing them the process of independent to make the progress of concurrence. This is the phases of concurrent one and parallel one. So concurrent one is a Q1 and vending machines are one. It will be in go for in a sequence manner. But in case of two, it will be in parallel, two queues and two vending machines. So it will be go for parallel and equal manner. It will be very useful to others. And real world applications, web services, multiple processing and data systems, and embedded systems, parallel algorithms, and a parallel file processing, and a parallel computing are main those are the main applications of POSIX. And also even having some challenges, the concurrency and the parallelisms, and the scalability and the performance portability and the fault tolerance and reliability and emergency efficiency were used in these mechanisms. Mainly the scalability developed the techniques handle the large scale of the system to increase the core control and the probability ensuring the performance to deliver the Hardware performance and the threats and its applications, emergency efficient to manage the consumption of maintenance and performance and worldwide, and it will be very useful even though having some challenges. And the concurrency management, synchronization, scalability, performance optimization, fault tolerance. Mainly the concurrency management effectively managing and concurrent development of multiple threads and to avoid the race conditions and deadlocks, and also synchronization to ensure the proper synchronizes between threads and prevent data current code maintain the consistency. Scalability threads using the baseline application to handle increasing the core count and workload and the density of multiple core and more presence, and also performance optimization to use the manage to load the balancing and task scheduling and the performance to effectively the tolerance. These are the main advantages. Thank you.